Okay, thank you. And thank you for coming to this session. As you can see here, this is based on a paper I presented last year. And if this presentation interests you enough to read the paper, I'm quite willing to send you one. What I'm going to talk about here is a little bit about the background, how I developed it, why I developed it, and what they are. Because I couldn't really figure out how to spend 30 minutes talking about knowledge readings. So I'm going to give you some of the context. So when we teach problem solving, systems engineering, my class is all about problem solving. When we teach problem solving, we teach problem, remedial action, we call that problem solving, and we take a solution. How many people here teach it like this? Nobody. Hey, that's good. Because that's the way it's done in mathematics, but in the real world, it's not done that way. In the real world, sort of moved it all down there, we start off with an undesirable situation where you have to work out what the problem is. And then you come up with a future conceptual, feasible, desirable situation, and then your problem is how do you transition from where you are now to the future without the problem? And at the end, after it takes time, how do you sort of test and make sure that you've actually solved the problem? So, in our classroom environment, we have an undesirable situation where we have a learning environment in systems engineering and project management that's not very effective. I get the impression, or at least I used to get the impression, that students that came into the class knowing something about it came out of the class knowing a little more about it. And students that came into the class knowing nothing about it came out of the class knowing a little less nothing about it. Think about that. And if anybody wants a copy of these slides, you don't have to take pictures. I'll send you them. So the feasible conceptual future situation is an effective learning environment. And the problem is how to transition. And the remedial action was the solution system development process. And so that's the solution. So you start by doing some observations. And you do some research. And you look into what makes teaching effective, how students learn, and then you put together a hypothesis, and that becomes your basic prototype classroom, and then you build it, test it, look back, and figure it out. But I've also noticed that, at least in my systems engineering class, we tend to leave out that research stage. And so people make the observation, and they think they have all the answers. They have all the information to create the answers in the class. So anyhow, I'm doing a bit of teaching while I'm doing this as well. So in the undesirable situation, let's take a look at it from different perspectives. And these are holistic thinking perspectives which go beyond systems thinking that I'm not going to talk about now, but I'm just going to use. So learning takes place in a classroom. The system consists of students, the instructor, technology, and the knowledge. The literature, on the other hand, discusses the need to improve the cognitive skills of systems engineers and project managers, but current courses don't seem to be doing that. They're focused on the knowledge. There's also a little bit of systems thinking, but it doesn't really do what they're supposed to do. So, from an operational perspective, the students are supposed to read the session material individually before the session begins. Then you have a lecture, and then you have a group exercise, and then you have a discussion. That's the traditional classroom. But in the real world, the students don't do the reading. They come to the class without the reading. So I tried to make the readings interesting. So one year I gave them a reading that was based on a paper called Applying Holistic Thinking to Optimize Your Sex Life. A paper on interface management. And the students read that because they commented it wasn't what we expected. So anyhow, but then I thought there must be a better way to get the students involved in reading. And so also students have different learning styles. Some students learn by seeing, some by hearing, some by videos, some by books, whatever. And then the teachers have different learning styles. Some like lecturing, some like discussing, some focus on different types of knowledge, etc. So how do you match these? If you don't match them, the students are bored, and they result poor performance, and then so the effectiveness of the delivery method has to be considered as well. And how many of you have seen Dale's cone of learning? or the learning pyramid? Nobody? Well, there was a study done a long, long time ago that measured the knowledge retention of students after 2 weeks based on different delivery methods. And you can see that lecturing gave them the lowest. Reading wasn't much better, and so on. But the best way of learning something was for the students or for people to learn it to teach others for immediate use. So I look at this and I say, hey, how can I get the students to do this? And the answer is the knowledge readings. So this is our traditional classroom, and that's sort of the flipped classroom where the students are learning it and teaching others. And so the knowledge readings come there. And so the desirable future conceptual, the feasible conceptual future desirable situation, I've got to come up with a better word for that, it's too long. So in systems engineering, somebody back in the National Academy in the US published the 5 top aspects of the engineering design process that they want the students to have. Be able to understand multiple solutions to a problem, oral communications, graphical, pictorial communications, the ability to handle open-ended, ill-defined problems, and systems thinking. And we generally teach that there's one solution to a problem. Well, in the real world, there's not. There's more than one solution to a problem. And so I like to sort of have grading that based on cognitive skills and knowledge on Bloom's taxonomy levels and go beyond systems thinking. So the solution is the balanced classroom, where you have a classroom session, you have a lecture that's pre-recorded ahead of time, then you have exercises in which the students apply the knowledge, then you have the knowledge readings, which I'm going to talk about, and then you have the individual assignment that you can use for assessment to see how much the students have learned. And if you sort of look at how they apply to the 5 top aspects, you can see that in the traditional classroom lecture, well, we can see they've listened to it, but have they actually learned it? They've received lectures and they've listened about systems thinking. And when you go into the exercises, they experience everything. And when you look at the knowledge readings, they experience it, but it still doesn't test this. But if you look at Bloom's taxonomy, on the other hand, you can see how the classroom comes together, because the exercises exercise the lowest 3 levels, and the knowledge reading exercise all the levels except for this one. So what are the knowledge readings? Well, there are readings associated with each session of the class. And so the students in teams have to take a reading and summarize the content. Then they have to list the main points. And then they have to prepare a briefing on 2 of the main points. But they're only going to present 1. The reason they prepare 2 is it gets boring if each of the teams present on the same thing. And so by preparing 2, if when a team comes up to present, another team's already presented that topic, they can skip and present their second topic. And then they have to reflect and comment on the reading. And notice the time, reflection and comment allocated more time than actual knowledge. And then they have to compare the readings, the content with other readings and external knowledge that they bring into the class. They have to state why the reading was assigned to the session, and then summarize the lessons learned. And then they have to switch team leaders for each session, and the whole presentation on that reading has to be less than 5 minutes. Now think about the cognitive skills involved here. They have to go through the knowledge, and they have to do a lot of thinking about it. And then they have to take a 10, 15-page reading and summarize it down to what are the main points. Now the smart students usually figure out that at the beginning and at the end of each reading there's an abstract and a summary which covers the main points. Some of the students don't get that. Well, look at the cognitive skills that they get to see, because when each of the students' teams are presenting the same material, so they're summarizing the same reading. But what happens is they pick out different main points, and they present differently. And so students begin to see that there are differences and similarities in what's being presented. And this exercises the high-order cognitive skills for identifying problem solvers, problem formulators, and innovators, based on the ability to find similarities among objects which seem to be different and differences among objects which seem to be similar. And none of this is in sort of any of the textbooks that I've seen, other than this is in the textbook on innovation. And now I can grade based on Bloom's taxonomy. My A's and A pluses are based on the higher levels. The B's deal with analyzing and applying. And the C's give you with the remembering and the understanding. And I share this with the students. And you can look at the grades. And before I started doing this, when I was back in Australia about 10 years ago, I noticed that students could demonstrate poor understanding of the material in class, yet get a high grade on the exam, because I was asking the wrong kind of questions. But when I started asking questions based on Bloom's taxonomy on the higher levels, I got to see the student behavior matched the exam results. And you can really adjust that to grade on a curve, because you change the levels, and you can fit that to a curve as NUS wants. So, results. Team presentations in each session differ. This illustrates to the students there can be more than one correct acceptable solution. The presentation provide excellent learning, I'll call it learning opportunities. The students make mistakes that I couldn't even imagine they would make. And so by pointing out the mistakes, and actually the students like being told what they've done wrong. It took me a while before I sort of started to tell students what they were doing wrong. And they picked up on it, and they really liked it. But of course, you have to tell them what's good as well. So I can go in there and say, and I'll give you an example in a moment. And then the presentations evolve. The students pick up techniques from the different classes. And so as the semester goes by, the students can actually see how much they're learning based on what's being presented and the type of comments that they get. Some students don't seem to be able to make the connections. They seem to take every session as totally different, and they can't build on it. Or they can't understand, or they can't see similarities that if I talk about problem solving and I talk about situation analysis, they don't seem to see the similarity of the analysis of problem solving is situation analysis, because it's called by different terms. And they don't see the similarities and the overlaps. And one of the other things I can do is when the students present the knowledge, if they misinterpret it, it's real easy to see because what they're presenting is wrong and it can be corrected. And some students misuse the type of charts because we don't really teach them what's the best kind of chart to use to present a certain kind of information. So here's an example. The students are presenting information about sensors, weapon systems, and C2 systems. Ignore what they are, but you can see how they use a stacked bar chart here. One team chooses to use a stacked bar chart. The other team uses a carrier radar chart. Which one provides the information in a better way? And the answer is it depends on the point you're trying to make. But by having the students do this, I can then sort of say, well, you know, in this situation, this type of chart's the one to use. And in that situation, that's the type of chart to use. And that never comes up in a normal lecture kind of thing. Click. Students who are used to classes where they're lectured at need to be shown why the knowledge readings have been introduced. And I have an introductory session at the beginning of the semester, and I teach them that, and I show them about how the learning is better this way, how will they learn things. And the student feedback is the knowledge readings are a lot of work, they've learned a lot, and the classes are changing the way they think. And I'll share some of the evaluations. Now, I teach this way in 4 different modules, one of which is an elective, and the others are all required modules. So when I go into the elective class, I sort of really stress the amount of work that the students have to do in the semester. And then by the end of the first week, my attendance has dropped 50%. All the poor students who are looking for an easy class have dropped out. And so we're left with a class of students that want to learn, which makes it really good. So in summary, the knowledge readings provide 3 of the top 5 aspects of the engineering design progress: multiple solutions, oral communications, and graphical pictorial communications. And I'm sure that this is not just confined to systems engineering and project management. It must apply in other areas as well. It allows students to exercise their cognitive skills at levels 3 to 6 in Bloom's, demonstrates that different people perceive information differently. So when the students do the knowledge readings, they can actually see that here's a section of a reading, and the different students are presenting it. When they're paraphrasing it, they're presenting it totally different ways. And the students can see that. And then I point out that when they are communicating to their people at work, they have to make sure that they're communicating very clearly, otherwise they can end up with this different kind of perceptions. Enables the instructor to correct any misinterpretations. I've met that. I've talked about that. Provide a better learning experience for the students, and it really does. However, it needs knowledgeable and competent instructors, because you have to know your stuff. If you're just teaching the textbook, you can't do this, because it's going to vary all over the place depending on how the students interpret it. So you have to be able to bring it back. And I do that in the lecture. Now, because of the knowledge readings takes a lot of time, especially when there's a large class, I pre-record my lectures. And I don't use Camtasia, sorry. I just use PowerPoint and an MP3 audio file. And that works very well. And so in class, at the end of the class, what I do is I go through the PowerPoint slides. Any questions? Slide 1, slide 2, slide 3, slide 4, slide 5. And the students will ask questions. Or when they listen to the lectures ahead of time, they will email me the questions and I'll answer them in class. And this makes this whole delivery format, it works in e-learning week and it works in face-to-face classroom. Because in e-learning week, the students record their presentations and put them in the IVLE. So each semester I generally have 1 e-learning week, and that's the university semester, and then in semester 2 I'm going to have 1 as well. Because if there's a week where I travel, instead of finding somebody else to cover for me, it's an e-learning week. Works very well. So, why you should do it? What's in it for you? Well, if you look at the evaluations from the Faculty of Engineering, you can see the numbers. That's the average. That was my scores, and that's the scores somewhere else. So the students seem to like it, which goes to tell that you get what you measure. Any other questions or comments? Today's presentation is based on this paper. It's on my website, or I can send it to you. And it's based on using an approach I call holistic thinking. And I have a book on that, which I give to my students. I give them a free PDF version of the book when sections of that book are used in my class. And so if anybody here would like a free PDF version of the book, I'm quite willing to email it to you. Any questions? In that case, I'll sit down. Thank you.